Alright, so now we have a couple of examples on solving systems of linear equations using matrix row transformations. This is part 2. Make sure if you haven't seen the first video, make sure you go back and see that one first. Alright, so let's use our system that we were playing with a minute ago. So we always start by writing the augmented form. So 2, 6, 16, 2, 3, and 7. And remember our goal, 1, 0, 0, 1. P and Q. If you forget your goal, you're going to get lost. Alright, so there are many ways to get from this form down to your goal, but I'm only going to talk about one very structured way. Alright, so here's the plan. You know you want a 1 in this first entry, right? This first column, this 2 right here, you want a 1. And the only thing that we can do are these 3 operations. To get this a 1, I'm going to encourage you to just multiply by a half. So what does that give us? Well, again, we're going to stay very structured and very neat here. So I'm going to write off to the side here 1/2 times row 1. And that's going to give us a new row 1. This is the notation I'm going to use to let me know what I'm doing from this matrix to this next matrix. All right, so when we do that, we get this new matrix. So 1/2 times row 1 is going to be a 1, a 3, and an 8. Right? Now, did we do anything to the second row? No. So we're just going to leave the second row alone for the time being. I don't want to do too much at once. Now, I'm going to go, and I encourage you to go column by column. Yeah, I know we want to get this 3 down here a 1, but more importantly, you want to get this 2 here a 0. So I'm going to encourage you to go column by column. Get the 1 where you want it, then get every other entry in that column a 0. Let all the other entries over here just turn out to be whatever they turn out to be. You'll get to them when you get to them. Alright, so our goal right now is to make this 2 a 0 using the 1 that we just got. This is where that third operation comes into play. Any row may be changed by adding to its elements a multiple of the corresponding elements of another row. Okay, so here's what we're going to do. How can we use this 1 to make this 2 a 0? And the plan is you want to multiply this 1 by something so that when you add it to the 2, it goes to 0. Well, everybody agrees that's a -2, right? So what we're going to write out here to the side is we're going to go, okay, -2 times row 1, and then we're going to add that to row 2. Now the row that you add to is the row that changes. So that's going to give us a new row 2. That's what this notation means right here. -2 times row 1 plus row 2 gives you a new row 2. Now, on paper, row 1 is not changing. So row 1 is going to stay put. We don't want it to change, right? Because we got the 1 where we want it. Right? It's going to change in our head. It's the row that you add to that's going to change. All right, so here we go. -2 times 1 gives you -2. Added to the corresponding entry in the second row, which would be this 2 right here, would give you a 0. And then you go right on across the row there. -2 times 3 gives you a -6. -6 added to the corresponding entry in the second row, which would be this 3 right here. So -6 plus 3 would be a -3. Alright, and then -2 times 8 would be -16. Add that to the corresponding entry in the second row, which would be a 7. And so -16 plus 7 would be -9. Everybody see that? It's this one that's going to take a little bit of digesting. Alright. So then you ask yourself the question, am I done with this first column? In other words, does it look the way you want it? Do you have your 1 where you want it and zeros everywhere else in that column? Yes, we only had 2 rows, so you got the 1 and the 0. Alright, so now, what do we need to do? I'm going to go up here. Now go to the next column and say, alright, where do I want my 1? Well, you want your 1 where this -3 is. So how do you make that -3 into a positive 1? Well, we go -1/3 times row 2, which gives you a new row 2. So what would that look like? So you'd have -1/3 times 0 is 0, -1/3 times -3 is 1, and -1/3 times -9 is 3. Did you do anything to the first equation? Nope, so we'll just leave it alone. All right, now you got your 1 where you want it in that column. Now everything else in that column, make a 0. So how do you make this 3 a 0 using this 1? Well, you go -3 times row 2 plus row 1 gives you a new row 1. Now on paper, row 2 is not changing. All right, so just go across. -3 times 0 is 0. 0 plus 1 is 1. We didn't want that to change. That's good news. -3 times 1 is -3, and -3 plus this +3 up here would be a 0. That's what we wanted to have happen. Then -3 times +3 is -9. -9 plus 8 would be a -1. And we've reached our goal. Now we can read off and say, all right, x equals -1, y equals 3. Or as an ordered pair, -1, 3. Follow me? First one is always the worst one to see. All right, there's a lot going on and there's a lot of places to make an error. I encourage you to go column by column because everything just plays out nicely. Now doing that, you're going to have to mess with fractions. That's just the way that it goes. There are other ways to avoid fractions, but to me personally, that's just too much work just to avoid fractions. We should not be afraid of fractions. All right, so see the next video on solving a system of linear equations using matrix row transformations. It's another example of two equations with two unknowns. Remember, the first example that you just saw here, it's always the worst one to see, so make sure you go see the next video. All right, study well, and please let me know if you have any questions.